Hi friends, let me introduce myself. I am Akshaya studying 2nd M.P.C. I am from the institution of TTWREIS, Ankampala. Now I am going to teach the subject chemistry. The topic is electrochemistry. What is electrochemistry? Electrochemistry is a subject. Electrochemistry is the study of production of electricity using energy which is released during a spontaneous chemical reaction. And once again repeating that, what is electrochemistry? It means electrochemistry is a study of production of electricity using energy which is produced during a spontaneous chemical reaction. What is the importance of this subject? It means by reading this subject, this is important for both theoretical and practical considerations. And why should we read this subject? It means by reading this subject, we are knowing that a large number of metals like sodium hydroxide, chlorine, fluorine and many other metals are produced by this electrochemical process. In our daily life, we are seeing a large number of batteries which are used in our daily life, and these batteries and fuel cells converts the chemical energy into electrical energy are using in a large scale in various instruments and devices. And the study of electrochemistry is important for creating a new technologies which are eco-friendly. And electrochemistry is a vast and interdisciplinary subject. Chemical reactions which are taken by the electrochemically is less efficient, is energy efficient and less polluting. The main topic in this electrochemistry is electrochemical cell. Electrochemical cell. What is electrochemical cell? A cell or a device which is used to convert the chemical energy into electrical energy is known as electrochemical cell. A cell which is used to convert the chemical energy into electrical energy is known as electrochemical cell. Who is the father of this electrochemical cell? It means Luigi Galvani and Alessandro Volta. These two scientists conduct experiment on conversion of chemical energy into electrical energy. The electrochemical cell is also called as galvanic cell or voltaic cell. And in any electrochemical process, electrons flows from one chemical substance to another chemical substance derived by an redox oxidation reaction. It means redox reaction. Redox reaction means in which reaction both oxidation and reductions takes place, the reaction is known as redox reaction. In which reaction both oxidation and reduction takes place, the reaction is known as redox reaction. What is reductant? Reductant is the substance that loses electrons and oxidized in the process. Reductant. What is reductant means? It is a substance that lost electrons and oxidized in the process. And what is oxidation? Oxidation is also a substance that gains the electrons and reduced in the process. And once again repeating that, redox reaction means in which reaction both oxidation and reduction takes place. The reaction is known as redox reaction. Let us take an example for clear understanding of redox reaction. A redox reaction can be described as the following. And a redox reaction have two half cell reaction. One is oxidation half cell reaction and another one is reduction half cell reaction. Let us take an example. In the image we are observing that zinc, metallic zinc react with copper ions to give zinc ions and metallic copper. Here zinc react with copper ions to give zinc ions and copper rod. In this reaction, zinc undergoes oxidation and gives electrons because it is a rich electron when compared to the copper. So, it is represented by negative sign. And once again repeating that, zinc undergoes oxidation. It gives electrons because of it is a rich metal when compared to the copper. So, it is represented by negative sign. Here zinc gives rise to Zn plus 2e electrons. It means Z gives electrons, so it is represented by plus 2. Here the oxidation state of zinc is increasing. And copper. In this reaction copper undergoes reduction. Reduction means taking of electrons. It is a poor electron. Copper is a poor electron because of because of it is a poor electron when compared to the zinc, and so it is represented by positive sign. Copper plus 2, Cu plus 2 plus 2e gives rise to Cu. It means that when copper takes electrons, when the copper ion take electrons to form a copper rod. Here plus 2, the oxidization state of copper ions is plus 2. When it react with, when it take 2 electrons, it forms copper rod. The oxidization state is increasing. And once again repeating that, redox reaction. Redox reaction means in which reaction both oxidization and reductions takes place. The reaction is known as redox reaction. And here in the above reaction, we observe that anode. Anode means zinc. Zinc is represented as oxidization. Oxidization is also called as anode. And in copper rod is represented as cathode. There are two types of electrochemical cells. There are two types of electrochemical cell. One is electrolytic cell and another one is galvanic cell. One is electrolytic cell and another one is galvanic cell. Electrolytic cell. Let us discuss about electrolytic cell. What is electrolytic cell? A cell in which electrolysis is carried out is known as electrolytic cell. A cell in which electrolysis is carried out is known as electrolytic cell. And in this electrolytic cell, electrical energy is converted into chemical energy. In this electrolytic cell, electrical energy is converted into chemical energy. In this electrolytic cell, a source of EMF like battery is used to convert the chemical energy into electrical energy. In this electrolytic cell, a source of EMF like battery is used to convert the electrical energy into chemical energy. And the medium through which the electrons flows from one chemical, the medium through which the electrons are enter the electrolyte or leave the electrolyte is known as electrode. The medium through which the electrons leave the electrolyte or enter the electrolyte is known as electrode. Electrode is represented as two types. One is cathode and another one is anode. Cathode. Cathode is represented by negative sign. It is the electrode which is connected to the negative terminal of the battery and through which the electrons enter the electrolyte. Cathode means it is electrode which is connected to the negative terminal of the battery and through which the electrons enter into the electrolyte. And another one is anode. Anode is represented by positive sign. It is also an electrode which is connected to the positive terminal of the battery through which the electrons are leave the electrolyte. And once again repeating that, cathode. Cathode means it is an electrode which is connected to the negative terminal of the battery and through which the electrons enter the electrolyte. And anode means it is also an electrode which is connected to the positive terminal of the battery and through which the electrons are leave the electrolyte. Electrolytic cell. We already discussed that electrolytic cell means in this electrolytic cell, electrical energy is converted into chemical energy. Electrical energy is used to produce a non-spontaneous chemical reaction. Electrical energy is used to produce a non-spontaneous chemical reaction. And in this electrolytic cell, electrons flows from anode to cathode, but current flows from cathode to anode. In this electrolytic cell, electrons flows from anode to cathode and current flows from cathode to anode. Let us observe the figure. In this figure, we are observing that electrical energy is a source in the form of battery is used to form a chemical reaction. In this electrolytic solution, two rods are dipped. One is represented as anode and another one is represented as cathode. And here we observe that electrons are flowing from one chemical substance to another chemical substance. It means electrons flows from anode to cathode, but current will flows from cathode to anode. And the second type of electrochemical cell is galvanic cell. The second type of electrochemical cell is galvanic cell. The cell which convert the chemical energy into electrical energy is known as galvanic cell. What is galvanic cell means? A cell which convert the chemical energy into electrical energy is known as galvanic cell. The first electrochemical cell was constructed by Galvani and Volta. So it is called as galvanic cell or voltaic cell. The first electrochemical cell was constructed by Galvani and Volta. So it is called as galvanic cell or voltaic cell. Let's observe the figure. In this figure, there are two beakers. One beaker is filled with zinc sulfide solution. In this beaker, we observed that zinc sulfide solution is filled. And in this zinc sulfide solution, zinc rod is dipped. In this zinc sulfide solution, zinc rod is dipped. And the adjacent beaker contains copper sulfide solution. The adjacent beaker contains copper sulfide solution. In this copper sulfide solution, copper rod is dipped. In this copper sulfide solution, copper rod is dipped. In this copper sulfide solution, when copper rod is dipped, it is represented as cathode. It is represented as cathode. In this zinc sulfide solution, when zinc rod is dipped, it represented as anode. The first beaker contains zinc sulfide solution, and which is zinc rod is stripped in this, and here the zinc is represented as anode. And in the adjacent beaker, it means second beaker, in this beaker copper sulfide solution is filled and copper rod is dipped. This copper rod is represented as cathode. Here zinc undergoes oxidization, it means give electrons, because of it is a rich electron when compared to the copper, and so it is represented by negative sign. And in the adjacent figure, we are dipping that copper rod. This copper rod is a poor electron, so it is taking electrons. It is represented as cathode. So it is represented as positive sign. In this copper sulfide solution, copper undergoes reduction. Reduction means taking of electrons, because copper is a poor electron when compared to the zinc. When these two rods are dipped in these two sulfide solutions, is connecting by a conducting wire, conductor and a bulb. Let us discuss briefly about working of galvanic cell. Let us discuss briefly about working of galvanic cell. Let us take an example where two metals are involved in a chemical reaction are zinc and copper. Let us take an example where the two metals are involved in a chemical reaction are zinc and copper. Since these two metals are involved in these two different sulfur, in these two beakers, are conducting by a conducting wire, conductor and bulb. An electric current would be formed when all electrons flows from one chemical substance to another chemical substance. For the transmission of electrons from one chemical substance to another chemical substance, we are using salt bridge. For the flow of electrons from one chemical substance to another chemical substance, we are using a salt bridge. Salt bridge is a inverted U-shaped tube. It is filled with agar-agar gel of KCl or KNO3. KCl means potassium chloride and KNO3. And instead of this salt bridge, we are also use that a porous pots or porous diaphragm. Instead of this salt bridge, we can use the porous pots or porous diaphragm, causing a half cell reaction with a wire so that a path can be formed for the flow of electrons through such a wire. It means when the flow of electrons takes place from one chemical substance to another chemical substance, then the produce electricity. When electrons flows from zinc to copper, then copper take the electrons which is given by the zinc, because of copper is a poor electron. In this diagram, we are observing that one beaker is filled with zinc sulfide and another beaker is filled with copper sulfide. In this copper sulfate solution, once again we are observing that zinc rod is dipped. Zinc rod is represented as anode. Anode means giving of electrons. Because of it is a rich electron when compared to the copper rod. So, when the zinc electrode lost electrons, the electrons are passing through the salt bridge and reach the adjacent beaker in which the copper sulfate solution is present. And when the copper ions takes the electrons which is given by the zinc, it takes and produce electricity. When the continuous flow of electrons from zinc to copper, then the electricity will be produced. When the electricity will be produced, then the connected bulb will be glow. When the flow of electrons, when the continuous flow of electrons takes place, then the electricity will be produced. When the electricity will be produced, then the galvanic cell will be glow. In this diagram, we are observing that here zinc is losing 2 electrons. We clearly see that zinc is losing 2 electrons. And when we see copper is taking 2 electrons. When copper take 2 electrons to make an elementary electron. Instead of salt bridge, we can also use that a porous pots or porous diaphragms. And let's discuss the differences between galvanic cell and electrolytic cell. Let's discuss the differences between galvanic cell and electrolytic cell. Galvanic cell, we already discussed that. Galvanic cell means a cell which converts the chemical energy into electrical energy is known as galvanic cell. Galvanic cell means a cell which converts the chemical energy into electrical energy is known as galvanic cell. And electrolytic cell. In this electrolytic cell is used to convert the electrical energy into chemical energy. In this electrolytic cell, electrical energy is used to convert the electrical energy into chemical energy. The energy is applied to the isotonic solution to bring about a redox reaction. In this electrolytic cell, electrical energy is used to bring up a redox reaction. And when compared to galvanic cell and electrolytic cell, galvanic cell converts electrical energy into chemical energy, but in electrolytic cell converts electrical energy into chemical energy. And in this galvanic cell, anode is represented as negative. Anode is represented as negative. And cathode is represented as positive. Anode is represented as negative and cathode is represented as positive. And when we see in electrolytic cell, anode is positive and cathode is negative. When we compare with galvanic cell and electrolytic cell, in galvanic cell, anode is negative and cathode is positive. In electrolytic cell, anode is positive and cathode is negative. The cell reaction which takes place at galvanic cell is spontaneous. The reaction which takes place at galvanic cell is spontaneous. In electrolytic cell, the chemical reaction which takes place is negative. The cell reaction which takes place in electrolytic cell is non-spontaneous. And in this galvanic cell, salt bridge is required for the flow of electrons from one chemical substance to another chemical substance. In electrolytic cell, there is no use of salt bridge. This is the main differences between galvanic cell and electrolytic cell. Galvanic cell and electrolytic cell. I am once again repeating that galvanic cell means a cell which converts the electrical energy into chemical energy is known as galvanic cell. First of all, we have discussed that electrochemistry. Electrochemistry is the subject which converts the chemical energy into electrical energy, and it is the subject for the production of electricity using a spontaneous chemical reaction. Electrochemical cell is a cell which converts the chemical energy into electrical energy. Electrochemical cell are two types. We have discussed that. First one is galvanic cell, another one is electrolytic cell. Galvanic cell means a cell which converts the chemical energy into electrical energy is known as galvanic cell. And electrolytic cell. Electrolytic cell is a cell which uses electric energy to convert into chemical energy. And in galvanic cell is used to produce electricity which is less polluting and energy efficient. In galvanic cell, when the continuous flow of electrons takes place, then the electricity will be produced. If there is no continuous flow of electrons, the galvanic cell will not be glow. It means the working function of electrons is not correct. And in electrolytic cell, electrical energy is used to convert chemical energy. And now I conclude that galvanic cell is quite simple. The working of galvanic cell is quite simple, and using a galvanic cell is useful to produce electricity which is less polluting. Thank you, sir. Thankful to Praveen Kumar sir for giving this wonderful opportunity, and my guide teacher and my principal sir and the teachers who are guided me, and my friends for giving opportunity. Thank you, sir.